In March of 1944, a German airfield in Mecklenburg became the center of one of the most consequential technical discoveries of the air war. Recline-Latz served as the Reich's premier aircraft testing facility, where teams of highly trained engineers and experienced pilots gathered to unlock the secrets of Allied air superiority. What arrived there in the opening days of spring would shatter German assumptions about American industrial capacity and fundamentally reshape military strategy over the coming months. On March 6th, a battered P51 Mustang touched down at Recline, shipped by rail from the crash site near Brandenburg. The aircraft had been forced down just 2 days earlier during the first major American fighter escort mission to Berlin. The pilot had perished in the violent impact, but the machine itself remained largely recognizable, offering German specialists their finest and most complete specimen, yet of the aircraft revolutionizing air combat over German territory. Werner Baumbach, a respected figure in aircraft development who would eventually assume command of a bomber unit, took charge of the initial assessment. Inside the cockpit, technicians discovered navigation charts belonging to the young American pilot. These maps traced a route from an airfield at Debden in England all the way to Berlin and back again, a total distance exceeding 1,100 miles. The technical staff began their examination at once, though initial skepticism filled the room. German intelligence had been monitoring increased American fighter activity over the continent, yet the prevailing wisdom held that single-engine fighters simply lacked the fuel capacity to reach the German capital and return home. The journey from English bases to Berlin measured roughly 560 miles in each direction. Conventional fighter aircraft, even those equipped with external fuel tanks, theoretically could not carry enough fuel for this journey while maintaining any combat effectiveness whatsoever. This conclusion rested on previous analysis of captured P-47 Thunderbolts and P-38 Lightnings, both of which had shown limited penetration before running low on fuel and being forced to retreat. Everything changed on March 4th and 6th. On the 4th, P-51 Mustangs from the 4th Fighter Group, operating their new aircraft for barely days after transitioning from older P-47s, had successfully escorted bombers to Berlin itself. Communication difficulties hampered this inaugural mission, with only 32 bombers reaching their target. Yet the significance proved unmistakable. American single-engine fighters had penetrated to the German capital, tangled with enemy aircraft, and made it back. 2 days later, approximately 660 bombers descended on Berlin in daylight, protected by over 150 P-51 Mustangs alongside P-38 and P-47 groups. The escort fighters battled Luftwaffe interceptors above the city and shepherded the bombers home. This was no accident. America had solved the fighter escort problem. General Major Adolf Galland, the commanding general of all fighter forces and a legendary pilot with more than 100 victories to his name, flew combat missions during this period despite his command responsibilities. He encountered P-51 formations himself and grasped the implications instantly. His official combat reports noted something that contradicted everything Luftwaffe intelligence believed. These American fighters were operating at full fighting capability over Berlin, engaging aggressively, showing no signs of fuel conservation at all. They possessed reserves. They were not straining at the edge of their capabilities. Galland emphasized in his assessments that the P-51 displayed remarkable superiority at altitude, outpacing both the Messerschmitt Bf-109 and Focke-Wulf FW-190 in speed and handling above 20,000 feet. The engineers at Recline began their examination by attempting to determine how the Americans had achieved this impossible range. They carefully measured the P-51B's internal fuel tanks. Twin wing tanks held 92 gallons each, totaling 184 gallons. The fuselage contained an additional 85-gallon tank mounted directly aft of the pilot's seat, a relatively recent design addition intended to extend operational range. Total internal capacity came to 269 gallons. The Packard-built Merlin engine, a licensed version of the British Rolls-Royce design that had transformed the Mustang's high-altitude prowess, consumed fuel depending on how hard it was being pushed. Under economical cruise settings, it burned roughly 60 gallons per hour. At normal cruise power, consumption rose to approximately 75 gallons per hour. German engineers performed calculations using these figures. 269 gallons at around 70 gallons per hour, cruise consumption yielded roughly 3.8 hours of flight time. At a cruising speed near 300 miles per hour, this suggested a maximum range of about 1,140 miles. Barely sufficient for the Berlin mission and return, with virtually nothing remaining for combat. Yet combat reports from German pilots told a different story entirely. They described American fighters engaging in prolonged dogfights over Berlin, some lasting 15 to 20 minutes before the Americans disengaged and flew home. Combat flying consumed fuel at rates exceeding 100 gallons per hour. The mathematics simply did not work. These fighters should have run dry before reaching the coast. The answer revealed itself when technicians examined the wing structure with greater care. The P51B possessed attachment points beneath each wing, designed for external stores, complete with fuel line connections. Drop tanks represented nothing new. German fighters had carried them since the Battle of Britain, with the Bf-109 using 300-litre tanks and the FW-190 employing them regularly for extended missions. The real question was not whether Americans used such tanks, but rather their capacity and how America produced enough of them to sustain operations. German search teams immediately began looking for evidence. Officers calculated likely jettison areas based on reported engagement locations. Fighters typically dropped tanks when enemy aircraft appeared, since external loads reduced both speed and maneuverability. Parties of Wehrmacht soldiers and Hitler Youth fanned across the countryside northeast of Berlin, combing fields and forests. Within 72 hours, several objects were recovered. Most had shattered completely upon impact, crushed beyond recognition. Yet 2 examples arrived at Recline in reasonable condition, having landed in soft soil or wheat fields that broke their fall. What German engineers found astonished them. The tanks measured approximately 108 inches in length, roughly 22 inches in diameter. Capacity calculations indicated each held about 108 American gallons, or approximately 400 liters. Paired tanks would add 216 gallons, bringing total capacity to 485 gallons. The Mustang could now operate for roughly 6.7 hours at cruise settings, achieving range exceeding 2,000 miles. Berlin suddenly became not merely reachable, but reachable with substantial combat reserves. What truly seized the attention of German technical specialists, however, was something far more unsettling. These tanks were not made of metal. Running fingers across the surface revealed something utterly unexpected. The silver paint coating the exterior concealed something fundamentally different from aluminum or steel. When engineers carefully scraped away paint near the tail section, they discovered multiple layers of heavy paper, each layer perhaps half a millimeter thick, compressed and bonded together using adhesive. The nose and tail cones had been formed from overlapping paper pieces shaped like papier-mâché. Each piece remained visible as a slight ridge where it met adjacent sections, creating a distinctive scalloped appearance. The central body consisted of seamless wrapping applied in continuous spiraling layers around a cylindrical form. Brass fittings, precision machined and carefully sealed, provided fuel connections. Looking through the filler opening revealed an interior finished with what appeared to be cellulose lacquer, designed to withstand aviation gasoline's corrosive properties. German materials experts were summoned to analyze the construction thoroughly. The paper proved to be kraft paper, manufactured through chemical pulping that produced remarkably strong cellulose fibers, the same material used for industrial shipping containers and packaging applications. The adhesive was identified as urea formaldehyde resin, a thermosetting polymer creating bonds stronger than the paper itself once heat-cured. At least 12 separate paper layers had been carefully oriented to provide strength in multiple directions. Interior wooden baffles prevented fuel sloshing during aerial maneuvers. The entire production process appeared standardized and designed expressly for mass manufacturing. The empty tank weighed approximately 80 pounds, comparable to a metal tank but smaller in capacity. Paper offered no significant weight advantage over steel, yet provided other benefits that became increasingly apparent. The revelation struck the technical staff with considerable force. Americans were manufacturing fuel tanks from non-strategic materials. Paper and wood-based resins required no aluminum, steel, or other metals, growing scarcer in wartime economies. Manufacturing required no specialized metalworking equipment, no highly trained metal workers, no welding or complex sheet metal operations. Factories that produced paper and packaging could easily be retooled to manufacture these tanks with minimal modifications to existing machinery. The United States possessed hundreds of such facilities. Converting even a tiny fraction of American paper production to tank manufacturing could yield thousands weekly. The tanks bore no serial numbers, no manufacturer identification, nothing suggesting limited production. They appeared to be commodity items, mass-produced and completely expendable. Intelligence officers began researching American paper industry capacity. Pre-war American paper production reached approximately 12 million tons annually, with wartime mobilization increasing this substantially. Converting merely 1% of this capacity to drop tank production would yield over 100,000 units monthly, far exceeding any conceivable P51 requirement. The genuine constraint would be manufacturing equipment and assembly labor. Yet this represented precisely the type of production that semi-skilled workers could manage after basic training. The paper tanks embodied industrial efficiency and resource optimization on a scale German planners found almost incomprehensible. Additional examination revealed further insights into the tank's engineering and operational use. These tanks were strictly single-use items. The urea formaldehyde adhesive, while creating durable bonds when cured, gradually dissolved through prolonged contact with aviation gasoline. Captured American aircrew under interrogation confirmed that paper tanks required filling immediately before departure and could not remain full for more than a few hours without developing leaks. This presented no operational limitation whatsoever. Fighters were always fueled during pre-flight checks. The tanks would serve their purpose during the mission, then be dropped away. The single-use design actually simplified logistics considerably. No recovery, no cleaning, no inspection or maintenance procedures. They were expendable by deliberate design. German analysts also noted the color scheme. Paper tanks received silver paint, while metal American tanks were painted gray. This distinction enabled ground crews to rapidly identify tank types during fueling operations. The silver finish on paper tanks reflected solar heat, reducing fuel evaporation and vapor pressure difficulties at high altitude. Every design element demonstrated systematic engineering optimization for mass production and practical field operations. By late March, German intelligence had traced these tanks' origins to British development. The Air Ministry in London had commissioned development of impregnated paper fuel tanks in 1943, specifically to conserve strategic aluminum. The Bowater-Scott Corporation, leveraging expertise in paper manufacturing, had developed and perfected the production process. Tanks entered RAF service during late 1943. American forces rapidly adopted the design, with multiple manufacturers in both countries producing tanks for USAAF fighter operations. British resource scarcity had sparked the innovation, yet American industrial capacity was exploiting it on unprecedented scale. The implications extended far beyond fuel tanks themselves. German technical staff initiated systematic review of all captured American equipment, searching for additional examples of industrial innovation and mass production methods that might reshape the air war's trajectory. The investigation revealed something that contradicted conventional wisdom. American equipment wasn't necessarily ahead of German technology when you looked at individual components in isolation. German optical systems frequently surpassed American equivalents, for instance. German firearms displayed remarkable sophistication in their engineering. German tank armor materials showed advantages in certain respects. Yet when you stepped back and examined the bigger picture, American equipment consistently demonstrated superior manufacturing quality, better standardization across units, greater dependability, and vastly superior availability. America's philosophy favored getting things made over getting them perfect. From the drawing board onward, designers built equipment that semi-skilled workers could manufacture using standard machinery. Every part fitted together without requiring a craftsman to hand-adjust anything. Mass production techniques shortened assembly times and expanded what factories could turn out. Germany's approach to building weapons told a completely different story. German weapons and equipment were frequently engineering marvels, assembled piece by master craftsmen with meticulous care. A German tank engine or aircraft power plant represented the absolute pinnacle of precision work. But that precision required master craftsmen, specialized equipment, and tremendous hours invested in each individual unit. The bottleneck wasn't ideas or materials. It was finding enough skilled people and specialized machinery to build them fast enough. America built good enough equipment by the millions. Germany built exceptional equipment by the thousands. When wars are decided by industrial capacity, quantity wins every time. The P51 Mustang story perfectly demonstrated this principle. British officials needed a fighter, so they came calling in 1940. North American Aviation designed the original prototype and delivered it in just 117 days. That's one of the fastest paths from contract to first flight ever achieved in aviation. October 26, 1940 saw that prototype take to the air for the first time. By 1944, North American had ramped up Mustang manufacturing to staggering levels across 2 factories. California's Inglewood facility was churning out roughly 364 planes monthly when running at full steam. Texas added more to that total through its Dallas operation. Together, both plants were delivering approximately 574 Mustangs each month through 1944. Production kept climbing as the year progressed. By January 1945, the monthly figure had surged to 881 aircraft. Building a single P51 demanded approximately 15,000 separate parts, manufactured by hundreds of suppliers scattered across America. Detroit's factories produced Packard-built Merlin engines at over 300 units monthly. Putting together each P51D consumed roughly 22,000 worker hours. The assembly line approach made this possible. Finished Mustangs rolled off the production floor every few hours. When operating at peak capacity, a brand new Mustang emerged from the factory approximately every 2 hours. Germany simply couldn't match this. Messerschmitt and Fokker-Wulf, even working around the clock and using forced labor, managed only around 600 fighters monthly in early 1944. America's aluminum production in 1944 reached approximately 1.25 million tons. That's roughly 2.5 billion pounds annually. This represented a stunning jump from just 164,000 tons back in 1939. Germany, by comparison, peaked at roughly 250,000 tons yearly, and that figure was dropping fast due to bombing raids destroying factories and the loss of bauxite mining areas. America had roughly 10 times Germany's aluminum capacity. Here's something revealing about American thinking. Drop tanks for carrying extra fuel were manufactured from paper rather than aluminum. This wasn't because aluminum was running out. America had more than enough to produce every drop tank in metal if leaders decided to. Paper was selected for solid, practical reasons. It cost far less, required simpler manufacturing equipment, preserved aluminum for other critical needs, and could be produced more rapidly with workers who didn't need advanced training. This was smart thinking, not desperation. The Luftwaffe's technical experts couldn't ignore what this meant. Those humble paper tanks became a symbol of something much larger, American industrial power and the enormous resource gulf separating the two nations. Luftwaffe officers displayed captured examples at technical briefings. Fighter pilots were shown the tanks and asked to think through what this meant for how they'd have to fight. The implication was impossible to miss. American fighters could now accompany bombers on missions deep inside Germany and stick with them all the way back. The old German approach, sitting back and waiting for Allied escort fighters to burn through their fuel and head home, was finished. Now German fighters would have to punch through those escorts to reach the bombers, and every such encounter would cost men and machines Germany couldn't afford to lose. Throughout spring 1944, Gallen presented his operational findings to top Luftwaffe commanders repeatedly. The P-51 outperformed German fighters above 20,000 feet, he stressed constantly. The Bf-109 couldn't match its speed at altitude, and the FW-190 couldn't compete with its maneuverability. With those paper drop tanks extending its reach, the Mustang could protect bombers across their entire route. German fighters were done attacking bomber fleets after escorts departed. Every contact now meant fighting through a defensive screen. Casualties were climbing rapidly. February 1944 saw the Luftwaffe suffer roughly 90 fighters, while inflicting around 150 Allied losses. By March, German losses jumped to approximately 160 aircraft, opposed to about 230 Allied losses. The direction was unmistakable and clearly unsustainable. America and Britain could replace what they lost faster than Germany could destroy it. The summer of 1944 brought the full weight of this imbalance down on German heads. The 8th Air Force flew deep raids almost constantly when weather cooperated. Mustangs stayed with the bombers from takeoff in England all the way to targets across Germany and home again. German fighter losses became catastrophic. June 1944 cost the Luftwaffe approximately 350 day fighters defending German airspace. July brought losses exceeding 350 single-engine fighters in the Western Theater alone, which represented a 31.2% monthly loss rate. August duplicated those numbers with a 36% loss rate. These casualty figures meant experienced pilots were dying faster than Germany could train replacements. New pilots arriving from flight schools had perhaps 150 flight hours, while American pilots typically had 300 hours or more. Many fresh German pilots had just 30 hours in their assigned aircraft before joining combat squadrons. This experience gap, combined with being outnumbered and constantly facing P51s, made daytime flying over Germany increasingly suicidal for Luftwaffe pilots. Galland filed one assessment after another with Hitler and top military leadership during these months. His September 1944 report laid it out plainly. Germany was losing the air war and couldn't win it back. The nation lacked the manufacturing base, the fuel supplies, the aircraft numbers, and the pilot reserves required to challenge American air dominance. America replaced losses quicker than Germany inflicted them. Industrial capacity gave the Americans an advantage Germany simply couldn't overcome through fighting. The only realistic option was preserving what remained for defending essential locations and hoping negotiations might prevent total destruction. Throughout late 1944 and into 1945, paper drop tanks continued raining down across the German landscape. Civilians became familiar with their distinctive shape scattered across fields and woods. Early reports often mistook them for unexploded ordnance, sparking panic until authorities explained they were just empty fuel containers. Civil defense officials issued notices clarifying that the silver cylinders descending from American planes were harmless fuel tanks, not weapons. Intelligence reports noted how this affected public confidence. Enemy aircraft overhead in such overwhelming numbers that their contrails formed webs across the sky, casually throwing away expendable fuel tanks, drove home a bitter lesson. While Germany fought for every drop of fuel and every ounce of aluminum, the Allies had resources to simply discard. German technical teams kept studying captured American equipment through 1944, but their focus shifted. Rather than learning how things worked, they were documenting just how wide the gap truly was. Could Germany manufacture paper drop tanks? Technically, yes. German chemical companies could produce suitable adhesives. German papermakers could fabricate the necessary material. The manufacturing itself wasn't complicated, but practically speaking, the answer was no. Germany's chemical sector was already running flat out producing rubber substitutes, munitions, and other essentials. Resin production for non-critical applications couldn't receive priority. Paper production was committed entirely to military needs. Maps, records, supplies. Most important of all, extended range tanks made no sense tactically. By late 1944, fuel scarcity was keeping huge sections of the Luftwaffe grounded. Flight training got cut to absolute minimums. Available fuel decided how many sorties happened, not available aircraft. Manufacturing extra tanks for range extension was pointless when there wasn't enough fuel for basic defensive flying. The situation contained a cruel paradox. The Americans had addressed fighter range through cheap paper tanks precisely when German fighters sat idle because they had almost no fuel. Two different challenges, two distinct industrial systems, two vastly different results. America possessed overwhelming abundance, more planes, more fuel, more pilots, more metal, more factories. and enough spare capacity to devise clever solutions like paper tanks. Germany waged war against constant shortages while facing an adversary that didn't face those limits. By January 1945, the outcome was certain. Soviet troops were crossing the Oder River, barely 50 miles from Berlin. Western forces had regrouped following their Ardennes counteroffensive and were advancing toward the Rhine. The Luftwaffe could offer minimal opposition, restricted by dwindling fuel and mounting pilot casualties. Technical analysis of American equipment at Rechlin continued, though it had become a formality. Researchers documented their conclusions for posterity, but these findings couldn't alter how things would end. Late January 1945 produced the final major study of the Mustang and its tanks. This comprehensive report examined every detail: the aircraft's range capabilities, tank construction techniques and materials, manufacturing volume, and what it all meant operationally. The verdict was unambiguous. The P51 Mustang carrying paper drop tanks made from ordinary materials has rendered the German heartland defenseless against American daylight bombing. Germany cannot manufacture fighters quickly enough to match American production, cannot generate sufficient fuel for the required combat intensity, and cannot train replacement pilots faster than losses occur at present rates. The document went into Air Ministry files in late January 1945, though whether top officials ever read it remains unclear. By that point, technical studies were simply putting numbers to what the fighting had already shown. The Luftwaffe that had controlled European skies in 1940 was reduced to scattered, desperate missions by early 1945, carefully rationing precious fuel for sorties that couldn't change anything strategically. American fighters roamed over Germany unchallenged, striking whatever targets presented themselves, protecting bombers, owning the sky completely. Every paper tank discarded from an American aircraft reinforced one unchanging fact: industrial power had decided the air war. June 1944 featured a major exhibition at Rechlin, where Luftwaffe personnel examined captured Allied equipment firsthand, including numerous P51 Mustangs, displayed alongside B-17 and B-24 bombers, P-38 Lightnings, Lancaster and Mosquito aircraft, Typhoon fighter bombers, and various Spitfire models. Thousands of Luftwaffe fighters and technicians walked through that exhibition, studying enemy hardware directly. The paper drop tanks received prominent display with technical diagrams illustrating their manufacture and range capabilities. This served as both a learning opportunity and a wake-up call. German personnel could witness Allied equipment quality, the interchangeable parts systems, and visible proof of massive manufacturing reach. Seeing this equipment physically, the same equipment they battled daily, made the industrial disparity real and tangible. Kampfgeschwader 200, the Special Operations Luftwaffe unit responsible for flying, captured enemy aircraft, operated multiple P-51s throughout 1944. These planes were flown for evaluation purposes, giving German test pilots hands-on experience with the Mustang's actual performance. These pilots consistently reported the P-51's outstanding cockpit visibility, particularly on later P-51D models equipped with the bubble canopy design. The Mustang proved remarkably stable once airborne, responding crisply to every control input and delivering outstanding performance even at the extreme altitudes where thin air challenged most fighters. The Merlin engine ran smoothly and reliably throughout every phase of flight, from takeoff to combat to landing. But what truly set the aircraft apart was something less glamorous, yet far more strategically significant: its remarkable range and staying power in the air. Equipped with a full load of internal fuel plus external drop tanks, the Mustang could stay aloft for more than 6 hours, undertaking missions that would have been completely beyond the reach of German single-engine fighters, even those carrying external tanks. The technical experts at Rechlin absorbed these capabilities with professional interest, and that knowledge began reshaping German defensive thinking as 1944 unfolded. Once Luftwaffe commanders recognized that American fighters could accompany bombers across entire missions, they attempted a new strategy, concentrating their forces at specific locations to achieve local numerical superiority at critical points. But achieving such concentration demanded precise coordination and exact timing. Scattered German units had to rendezvous at designated locations, assembling into formations large enough to pose genuine threats against the heavily protected bomber streams. Weather, fuel shortages, and breakdowns in radio communication frequently prevented these concentrations from coming together. And when German pilots did achieve favorable tactical positions, the presence of Mustangs and other American fighters made any assault on the bomber formations devastatingly expensive. The entire strategic picture had undergone fundamental transformation. During 1943, bomber streams, whether poorly protected or unescorted, had suffered horrific losses. By the middle of 1944, the situation had reversed. Now it was German fighters attempting to reach the bombers that absorbed the catastrophic casualties. The paper tanks themselves became unexpected collectors' treasures after the fighting ended. Relatively few examples survived undamaged, since most were torn apart on impact or deliberately destroyed by Allied ground crews to prevent German forces from retrieving and reusing them. As disposable items, they held little material worth, yet the handful that endured transformed into museum pieces and historical curiosities. The National Air and Space Museum in Washington houses several in its collection, displayed near the very Mustangs for which they were engineered. The museum placards explain their humble construction, laminated craft paper infused with phenolic resin, and catalogue the manufacturers like Bowater Scott, along with their capacity of 108 gallons. What those placards rarely mention, though, is something far more revealing. German engineers spent weeks at Rechlin studying these captured tanks, performing calculations and grasping through them the full extent of Allied production power. The story lives on in technical reports and post-war interviews, disclosing the profound psychological impact on German technical personnel. They confronted no mere superior weapon. The paper tank represented no advanced technology whatsoever. It was deliberately stripped down, designed with simplicity as the goal, constructed from materials of no strategic importance. Yet that very simplicity carried a message more crushing than any technical marvel could have conveyed. The Americans possessed such boundless industrial capacity that they could afford to prioritize mass production efficiency over individual performance. They manufactured fuel tanks from paper because they had endless supplies of paper, endless resin, endless factory capacity, and endless fuel to fill the tanks. Their optimization sprang not from desperation, but from opportunity. Germany's engineers grasped this immediately. They understood they faced no enemy frantically improvising with substitute materials. They opposed an adversary so resource-rich that making substitutions represented a deliberate choice for efficiency rather than a survival necessity imposed by scarcity. When Allied interrogators questioned Luftwaffe personnel after the war, they returned repeatedly to this revelation. When asked to identify the moment they first understood Germany could not win, many technical specialists and senior commanders pointed to early spring 1944. The arrival of long-range fighter escorts reaching Berlin marked the pivotal instant when the strategic balance shifted irrevocably. Hermann Göring, questioned in captivity, acknowledged that long-range fighters had delivered a crushing strategic blow against German defensive preparations, and ranked among the war's most decisive elements for the ultimate air campaign outcome. Though the precise quote attributing Germany's defeat to Mustangs over Berlin lacks verification in primary source documents, Göring's post-war statements repeatedly confirmed that Allied air superiority, made possible by long-range escort fighters, had proven decisive in Germany's collapse. The technical insights gained by German engineers who examined captured Mustangs and their tanks contributed substantially to post-war aviation advancement. Numerous such engineers eventually settled in the United States or collaborated with Allied technical intelligence after the war concluded. Their sophisticated knowledge of American production techniques and design philosophy shaped their subsequent professional work. The concepts of standardization, parts interchangeability, and designing for manufacturability became cornerstones of post-war aircraft development. The paper drop tank itself evolved into a teaching case study in wartime industrial innovation, featured in engineering curricula and military staff colleges worldwide as a demonstration of how resource optimization and mass production could deliver strategic triumph. The Mustang itself remained in military service across multiple nations for decades following 1945. During the Korean War, it saw extensive combat, primarily carrying out ground attack and close air support missions against enemy forces and installations. The very characteristics that made it exceptional as an escort fighter in Europe, outstanding range and remarkable endurance, proved equally valuable in Korea's drastically different combat environment. Some air forces maintained operational Mustangs well into the early 1980s, testament to how soundly the fundamental design had been engineered. More than 15,000 rolled off assembly lines during and immediately following the war, making it among the most extensively produced American fighters of its generation. Presently, over 150 airworthy examples continue flying, lovingly maintained by private collectors and museum organizations across the globe. Witnessing a Mustang in flight, frequently still bearing the distinctive paint schemes of its wartime squadrons, provides a vivid connection to the aircraft's contribution in establishing Allied aerial dominance across Europe. The historical significance of the Mustang and its paper drop tanks reaches far beyond their tactical or operational contributions. They constitute a compelling case study in industrial warfare and the crucial role production capability plays in modern combat. World War II was fundamentally determined not on battlefields but within factories. Whichever side could manufacture greater quantities of weapons, ammunition, aircraft, vehicles and supplies faster than combat consumed them, possessed an unbeatable strategic advantage. American industrial mobilization achieved unprecedented scale in human history. Manufacturing output from 1943 through 1944 saw American factories assembling aircraft at astonishing rates exceeding 50,000 yearly. Ships departed shipyards at multiple vessels daily, while ammunition production reached billions of rounds. This enormous industrial flow sustained American forces while simultaneously supplying substantial quantities through Lend-Lease to Britain, the Soviet Union, and other alliance partners. Germany, despite possessing considerable industrial capacity and sophisticated technical expertise, could not approach the Allied output volumes. Multiple factors contributed to this disparity. Germany possessed a smaller industrial base. Strategic bombing progressively destroyed production facilities, loss of territorial control eliminated access to raw materials. Competing military programs diverted resources away from aircraft production, and organizational and planning inefficiencies hampered productivity. Most fundamentally, though, Germany faced a coalition whose combined industrial might dwarfed German capacity several times over. When American productive power joined the alliance and reached full mobilization during 1942 through 1943, German defeat became mathematically inevitable as that production ramped toward its enormous peak. The paper drop tanks descending on German territory throughout 1944 and 1945 symbolized this industrial reality in language so straightforward and unambiguous that its meaning could not escape comprehension. German technical intelligence services had systematically and professionally examined captured American equipment throughout the entire conflict. Testing centers like Rechlin preserved meticulous records documenting performance data, material composition analysis, and technical evaluations. Many such documents survived the war's conclusion within various archives, offering historians invaluable contemporary perspective on how each adversary assessed the other's technical capabilities. German technical evaluations of American equipment generally proved accurate when judging specific technical merits. They correctly identified the particular strengths and particular weaknesses inherent in American aircraft, vehicles, and weapons systems. Where German analysis fundamentally broke down was not in assessing individual pieces of equipment, but in comprehending the staggering magnitude of American production and what that magnitude signified regarding the conflict's ultimate outcome. One Mustang represented a genuinely outstanding fighter. 10,000 Mustangs constituted air superiority that no amount of tactical brilliance or technical innovation could successfully oppose. The narrative of German engineers at Rechlin in March 1944, examining paper drop tanks, ultimately addresses the essence of industrial warfare. It demonstrates that when industrialized nations clash, Manufacturing capability becomes as consequential as battlefield performance. Nations that manufacture greater quantities, faster and more efficiently, possess advantages that even exceptional tactical ability and technical achievement cannot fully overcome. This lesson, acquired through terrible sacrifice by both Germany and Japan during the Second World War, influenced Cold War military planning and continues shaping strategic doctrine in the contemporary world. The capacity to sustain ongoing production of sophisticated weapons, maintain functioning supply chains under combat stress, train replacements faster than combat depletes personnel, and consistently outproduce opponents across extended timeframes remains as vital now as it was in 1944. The March 1944 missions penetrating to Berlin, protected throughout by single-engine fighters, represented a decisive turning point in the European air struggle. After that historic moment, no German location lay beyond reach of American bomber formations when accompanied by fighter protection. The relentless bombing offensive could continue with casualties remaining substantial yet sustainable. Mounting pressure squeezed German military production. Plants producing synthetic fuel, factories assembling ball bearings, aircraft assembly facilities, and transportation infrastructure all became targets vulnerable to repeated attacks. Now feasible with Escort fighters present from beginning to ending. The accumulated impact of this intensifying campaign, coordinated with Soviet advances pushing westward and Allied forces advancing from other directions, delivered Germany's defeat just 14 months following the first Mustangs' arrival over Berlin. The paper drop tanks persisted throughout this final phase of European warfare. Manufacturing continued unabated through 1945, with thousands leaving factories monthly. Beyond Mustangs, Thunderbolts and Lightnings relied on paper tanks as well, gaining extended operational radius. British fighter squadrons also depended heavily on paper tanks for extended range operations against targets across occupied territories and Germany proper. The Royal Air Force's Mustang wings employed them extensively for far-reaching missions over enemy-held regions. The efficient paper tank production liberated aluminum and steel for other military applications, while simultaneously delivering the range extension essential for sustained strategic operations. This intelligent matching of production methodology to actual requirements, prioritizing practical efficiency ahead of conventional approaches, exemplified the industrial philosophy guiding Allied warfare throughout the entire conflict. Modern historians examining the European air campaign recognize numerous factors contributing toward Allied victory. Allied pilots flying superior aircraft types, technological edges in fields including radar and information systems, coordinated strategic bombing targeting German industry and transportation, and unrelenting combat operations steadily consuming German resources faster than replacement proved attainable. The Mustang and its paper drop tanks held genuine significance within this multidimensional struggle, though they did not represent a single decisive element in isolation. Triumph in the air resulted from coordinated action across fighter types, bomber forces, continuous manufacturing, personnel training programs, intelligence operations, tactical advancement, and persistent dedication of material resources. The paper tank symbolized one facet of this comprehensive enterprise, important because it so plainly embodied the industrial predominance underlying Allied achievement. The technical records preserved at Rechlin documented American capabilities with characteristic German precision. German engineers catalogued specifications, performance information, manufacturing approaches, and production volume estimates with the meticulous attention typical of German technical investigation. These surviving records, maintained in various archives, including the Bundesarchiv, furnish historians with detailed period assessments of Allied capabilities as observed through German technical expertise. Examining these documents today, equipped with historical perspective and complete access to American documentation, reveals that German technical assessment proved substantially correct. They comprehended American capabilities thoroughly. What remained beyond their capacity to address was the strategic predicament those capabilities embodied. Recognizing that an opponent possesses overwhelming advantages, fails to provide solutions for neutralizing such advantages, when those advantages stem from fundamental inequalities in industrial capacity and resource abundance. The paper drop tank's significance transcends its original wartime purpose. It serves as powerful testimony that effective answers need not be technically intricate or impressive in their sophistication. A tank fabricated from adhesive bonded paper, engineered for single use, manufactured from non-critical materials, represented a perfectly suited answer to the particular challenge of expanding fighter range. It functioned adequately for its purpose. This philosophy, developing solutions adequate for specific requirements rather than pursuing perfect technical answers, developed into a governing principle in contemporary systems engineering. The optimal solution rarely proves most technically complex. The optimal solution accomplishes requirements while remaining producible in necessary quantities within available timeframes, employing accessible resources. This wisdom, imparted through paper drop tanks scattered across Germany, maintains relevance for both military and civilian problem-solving today. The aircraft transporting those drop tanks, the Mustang, ranks among aviation's most accomplished fighter designs. Its blend of extended range, outstanding performance, unfailing reliability, and suitability for mass production rendered it ideal for escorting bombers throughout strategic campaigns. Multiple elements combined to generate the Mustang's combat effectiveness. The aerodynamically refined fuselage crafted by North American's design specialists under Ed Schmud's direction, the potent and dependable Merlin engine, the addition of fuselage fuel storage that expanded operational capability, and the availability of drop tanks extending tactical radius beyond 800 miles, all contributed essentially. No single component alone produced the Mustang's impact. The integrated combination of all components, sustained by industrial power, enabling mass manufacture, established the Mustang as the indispensable escort fighter throughout the European Air War. 8 decades following the March 1944 events, the lessons retain instructive power. German engineers' investigation of captured equipment at Rechlin unveiled not merely technical specifications, but fundamental strategic truths. The paper drop tanks revealed that American industrial capacity surpassed Germany's ability to replicate, that American engineering prioritized workable solutions over technical virtuosity, and that Allied resource abundance permitted efficiency optimization rather than forced desperation substitutions. These discoveries, occurring in March 1944, when victory remained uncertain, though the trajectory grew progressively apparent, gave German technical personnel direct comprehension of their predicament. That comprehension, regrettably, could not alter outcomes. Circumstances beyond facility engineers' authority determined Germany's ultimate fate. Yet the account of those engineers examining cylinders of adhesive kraft paper, computing fuel volumes, and comprehending the implications for aerial combat illuminates how industrial capacity ultimately determines modern warfare's outcome. The conflict concluded in May 1945. The coordinated bombing campaign, made feasible through long-range fighter protection, including Mustangs carrying paper tanks, contributed substantially to German capitulation. Manufacturing had suffered disruption, transportation systems lay devastated, fuel reserves lay exhausted. The Luftwaffe had diminished to a marginal force. These consequences flowed from multiple factors interacting across years. But the capacity to shepherd bombers across entire missions above Germany, made possible by fighters like the Mustang equipped with paper drop tanks, ranked among the most consequential elements determining outcome. The paper drop tanks, surviving combat, became museum pieces and historical artifacts. Most disappeared through destruction or disposal, though a few eventually reached collections. Their true significance transcends the physical objects themselves, residing instead in their representation of industrial strength channeled towards strategic purpose, practical technology addressing specific challenges, and the dominant advantage held by overwhelming production capability in contemporary warfare. That legacy, captured within technical files from Rechlin and comparable archives, continues illuminating understanding of the Second World War and the character of industrialized conflict.